So welcome everybody to our third installment on partial fraction decompositions. All right, so in this video, let's look at something we might call a linear factor shortcut in our partial fraction decomposition. So suppose we're given something like an x minus 1, an x minus 2, and x minus 3 as factors. Well, in our partial fraction decomposition, we know that's going to look like an a over x minus 1, a b over x minus 2, and a constant c over x minus 3, and we have to figure out what those constants are. Well, if we go through and we clear our denominators, just like our first step in the previous video, then we're going to get something that looks like x squared minus 22x plus 18 times, or equal to a times x minus 2 times x minus 3 plus b times x minus 1, x minus 3, plus c times x minus 1 and x minus 2. So if you go through and clear your denominators, that's the kind of expression that you're going to find. Now what we did in the last video was expand all of these things, combine powers of x, and form a linear equation. Well, another kind of shortcut that we can do when we have these linear terms, we can choose values of x, which will cancel terms. Okay. Okay, so what we had when we expanded, or when we cleared denominators, was we had an a times our x minus 2 and x minus 3, b times x minus 1, x minus 3, and c x minus 1 times x minus 2. So if we choose values so that terms cancel, what if we choose something like x being 1? So if x being 1, then what happens for our b term, having the x minus 1, plugging in x minus 1 there, that term is going to go to 0. Likewise, if I have an if x is 1 in my c term, c times x minus 1, that one is also going to go to 0. And so my terms b and c all go away. What I'm left with is an expression for a. So if I plug in 1 over on the left, what do I have? Well, 6 minus 22 plus 18. Then over on the right, I have a times 1 minus 2 and 1 minus 3. So I get something that looks like 2 over on the left, and minus 1 times minus 2 over on the right, and so I get 2 is equal to 2 times a. And in that case, what happens? Well, it's pretty easy to see that a is just going to be 1 in that case. And so this kind of gives me an easy way of figuring out what my coefficients are going to be when I have linear factors for which I can just plug in the appropriate value for x. Now let's see what happens with b and c. So now what happened from the last one, we knew that a was going to end up being 1 from that value. And so what happens if I choose a different value? Well, what I notice with my b term, I'm missing a factor of x minus 2. So let's say that we let x equal 2. In that case, what happens? Over on the left, we have 6 times 2 squared, 22 times 2 plus 18. And then over on the right, we have 2 minus 2, x minus 3, plus b times 2 minus 1, 2 minus 3, and c times 2 minus 1 and 2 minus 2. So the same thing happens when I have my 2 minus 2's. Those go to 0. My 2 minus 2, that term goes to 0. And so I am just going to be left with a negative 2 over on the left. Whoops, wrong color. Let's go back to the right color. So I get a negative 2 over on the left. Over on the right, I have 1 and a negative 1, so I have a negative b over on the right. And so it's an easy way to see that, oh, b is just going to be 2 in that case. And so I can do this one more time to figure out what c is going to be.